Hi everyone, let's take a look at the following. Sketch f of x, which equals to x times in brackets x squared minus 4, close bracket to the power of 1 over 3. Step number 1. If you think about the domain in this case, x is going to be an element of real numbers. And because it's not going to be a fraction, you can even state the fact that there will be no asymptotes for this graph. So there will be no vertical, horizontal, oblique asymptotes. And of course, if the function is a fraction, then in those cases, you may have some of these asymptotes. Step 2. To find the intervals of increase and decrease, you first have to find the critical point. And to do that, you have to take the derivative by using the product rule. Step 1, differentiate the first. Step 2, copy the second part, plus copy the first part. And the final step is to multiply by the derivative of the second part. And again, notice the chain rule inside the product rule. To find critical points, you have to combine this as one fraction. So I'm going to express the first one as x squared minus 4 to the power of 1 over 3 divided by 1 plus 2x squared divided by 3 times x squared minus 4 to the power of 2 over 3. And again, to combine this, I need to multiply the first fraction by the missing common denominator. And when you do this, you have to look at the top and the bottom, and we'll divide the page into two different columns. So 0 equals to, again, if you expand this, that's going to be 3 times x squared minus 4. That's going to be 3x squared minus 12 plus 2x squared divided by the common denominator, 3 times x squared minus 4 to the power of 2 over 3. Now, again, you divide this into two columns because you have to look at f prime equal to 0. So if you look at the top, that's going to give you 5 x squared minus 12. And again, at this point, I know you know how to solve this. X squared is going to be 12 divided by 5. Don't forget there are two cases. You got to take the square root for both the positive and the negative case. Now, I'm going to take the calculator and work this out with you. At any given time, you can press pause, make sure you confirm you get the same numbers, and if not, you can comment below. So on my calculator, this will give you plus and minus 1.5. And again, you form the habit of plugging these back in to find the corresponding y values. So what I mean is you plug it back into f of x and you solve for y. Again, you can press pause at any given time just to confirm you get the same numbers, and if not, please comment below. So those are two critical points. But the second part, and again, this is something that we didn't do so much in the previous video, is when f prime does not exist, or when f prime is undefined. You can call it either way, that's fine. And I did mention most cases, those are vertical asymptotes. And this is one of those cases where it's actually inflection points, as you would discover. So you do make the denominator equal to 0. And again, if you go through the mental math, x squared is going to be 4. You take the square root of both sides. Don't forget, there are two cases. So x is going to be plus or minus 2. Always form the habit of finding the location, not just the x value. And again, you can verify that. Now, always graph as you go. So in the first case, I have negative 1.5, 1.8. So you label that, negative 1.5, 1.8. There's also positive 1.5, negative 1.8, which would be somewhere there. Also 2, 0, and negative 2, 0. And again, we haven't confirmed if they're max or min yet, and we'll do this at the very end. To find the interval of increase and decrease, again, you can draw the number line, look at the anchor points. This doesn't have to be the scale. And again, if you go from left to right, you have negative 2, negative 1.5, 1.5, and 2. Now again, you can take the calculator, plug in these numbers back into f prime, and to be very clear, you're plugging it back to f prime, which equals to 5 x squared minus 12 divided by 3 times x squared minus 4 to the power of 2 over 3. And you can write down if it's going to be increasing and decreasing. And I'm here to tell you, when you work this out, it should look something like this. increasing, then it's going to be from negative 2 or from negative 2 to negative 1.5, that's going to be increasing, decreasing, increasing, increasing, just like that. So let's keep going. Once you find this, you can move on to the points of inflection and concavity. And to find f double prime, again, you have to go through the derivative, and in this case, you can apply the quotient rule. So step 1, you square the bottom. Step 2, copy the bottom to the top. Step 3, you multiply by the derivative of the top minus. Second last step, you copy the top. And the final step, you multiply by the derivative of the bottom. And again, notice you're applying the chain rule inside the quotient rule, just like that. Just like increase and decreasing, when you find the concavity, or before that, when you find the inflection points, you look at two things. You look at the top, you also look at the bottom. So again, you can rewrite this as 30x times x squared minus 4 to the power of 2 over 3 minus 4x times 5x squared minus 12 divided by x squared minus 4 to the power of 1 over 3. Again, this is all over 9x squared minus 4 to the power of 4 over 3. And to combine the two fractions at the top, you have to multiply the first fraction by the missing common denominator, which is x squared minus 4 to the power of 1 over 3 divided by itself. And effectively, you're multiplying it by 1, so you're not changing the actual fraction. Now again, divide this into two different columns. And the first column is what happens at the top, and the second column is what happens at the bottom. If you combine this, this would give you 30x times x squared minus 4 minus 20x cubed plus 48x divided by x squared minus 4 to the power of 1 over 3. And this is kind of in the second column. We'll kind of take care of that because it's still one denominator. Now, if you only focus on the top and expand this, that's going to be 30x cubed minus 20x cubed. That's going to be 10x cubed. And of course, negative 120x plus 48x, that's going to be negative 72x. This means you can factor a common 2x at the front. In the brackets, it's going to be 5x squared minus 36. So one answer is going to be x equal to 0. And of course, if you look at the second case, x squared equals to 36 divided by 5. Don't forget, when you take the square root, there are two cases, plus and minus. And again, if I take my calculator and I work this out with you in real time, this is going to give you plus and minus 2.7. Plus and minus 2.7. And again, always form the habit of finding the location and not just the x components. And again, any given time you can press pause, and when you press play again, I'll be right here. When you plug in 2.7 back into the function, that's going to give you approximately 4. So for 2.7, it's going to give you negative 4. For negative, not negative 4. For 2.7, it's going to give you 4. And for negative 2.7, it's going to give you negative 4. Now, if we move on to the second column, this is exactly what we discovered for critical points. Ultimately, you're looking at 9 times x squared minus 4 to the power of 4 over 3 or 5 over 3. It doesn't even matter because x squared equals to 4, which means x equals to plus or minus 2. Again, when you take the square root, there are two cases that you're thinking about. And we knew this even from the critical point where we found the same exact coordinates. Except now, we've identified them officially as inflection points. So again, there are 5 points. You keep going back to the graph, and you label this. So you go 2.7 and 4. You can go negative 2.7 and negative 4. And these are inflection points. 0, 0, that's the inflection point. That's an inflection point. 2, 0 now officially is an inflection point. Likewise, negative 2, 0, inflection point, just like that. Now we can move forward and work on concavity. So if I go back here, you can draw a number line, and again, you can press pause. You can confirm this on your own, but what I'm trying to tell you is when you plug all these back in, you should get the following. So again, the anchor points are from negative 2.7, negative 2, 0, 2, 2.7. Take the calculator, plug it back into f double prime. And again, f double prime is 10x cubed minus 72x divided by x squared minus 4 to the power of 1 over 3. When you plug it back in, you will discover it is concave down, concave up, concave down, concave up, concave down, and concave up. Now here comes the most important step, and then we'll talk about max and min. This is where you take everything, every single point, and there's 7 of these, 1, 2, 3, 4, 5, 6, 7, and you take the superposition of all the increasing, decreasing, and concave up and concave down together. And when you do that, you can officially graph it. So again, if you just look at the previous table right here, increasing, decreasing, I'm going to copy that. And this will give you, again, increasing, 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 decreasing, decreasing, increasing, 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 and likewise, concave down, concave up, concave down, concave down, concave up, concave up, concave down, and concave up. And again, we did this in the warm-up for 4.5, so make sure you know how to draw the 4 different pieces. If the graph is concaved up and increasing, it's going to look like that. Concave up increasing, concave down increasing, concave down decreasing, concave up decreasing, concave up increasing, concave down increasing, and concave up increasing. We're going to take all of these different parts and piece them together. You go back. Again, if you make this a little bit more dramatic, it's going to look roughly something like that. Then, in the next piece, it's going to look something like that. Then like this, then like this, then back to the bottom, back to the top. And again, if you make it a little bit dramatic, it looks like that. Then it continues looking like that. And that's going to be the function f of x. Now the only thing left is max and min, and again, I'll leave that to you. You can use the first or the second derivative test to show this, but from the graph you can tell this is going to be the maximum. And likewise, this point is going to be the minimum. And that is how you sketch f of x equal to x times x squared minus 4 in brackets to the power of 1 over 3. I hope this makes sense.